All right, thanks for joining us today on the first ever Real-Time Weekly Show. So thanks for being here. Thanks for being a part of the Real-Time Week newsletter community. We talk every week in the newsletter about real-time technologies like WebRTC, WebSockets, and more. And I'm really pleased today to do our first webinar, our first live conversation on WebRTC, of course, about the WebRTC Data Channel with Dennis Mårtensson from Greta.io. So thanks for being here, Dennis.
Thank you for having me.
Excellent. We're just going to go through a couple of introductory remarks and a little bit of housekeeping, and then we'll jump into the conversation here. First, I want to say thanks to our sponsor, WebRTC.Ventures, which is our development company here behind Real-Time Weekly. I'm the CEO and co-founder of WebRTC.Ventures. We are a design and development agency that specializes in building WebRTC-based applications for a variety of industries, web and mobile. And if you're interested in learning more and talking with us, just check us out at WebRTC.Ventures. And if you're not familiar with it already, we do have Real-Time Weekly, which is a free weekly newsletter that we send out. You can sign up for that at realtimeweekly.co. And if by chance you are in South America or in Argentina in particular, coming up in June, we're going to do our first ever in-person event through the Real-Time Weekly group. It's WebRTC Argentina in Buenos Aires on June 15th. And I also want to thank Twilio, who is our sponsor for that event. So that's the housekeeping part. In case you're not familiar with the data channel, I'm just going to say a couple of quick words about that, and then we'll turn it over to the expert here, and Dennis. Most people are familiar with WebRTC specifically around video chat, the peer-to-peer video and audio channels between web browsers, and you can also port it to mobile. But there is this other part of it that is often forgotten about called the data channel. And just like the video and audio streams, it's fully peer-to-peer, it's encrypted, and you can use it over a protocol similar to WebSockets. So there are a number of reasons that people typically use the data channel for. Probably the most common is text chat to go along with video chat in your application. You could also break up files into small chunks and send them over as a peer-to-peer file transfer during a conversation if we wanted to share a document, for example. Or we might do things that have nothing to do with the video chat part of WebRTC, such as maybe exchanging sensor data or real-time data dashboards, maybe commands and controls in a gaming application, or the one that we're going to start out focusing on today, content delivery networks. And as you may already know, a content delivery network is a commercial service that hosts the images and other static assets from your site around the world on different servers so that visitors get that content served to them faster from a more local server. If you combine that with the data channel of WebRTC, we might also be able to share some of that content peer-to-peer between those users without even touching the content delivery network. So that's what we're talking about today. So to guide us through that conversation and tell us about his experience is Dennis Mårtensson. Dennis is the Chief Technology Officer and co-founder of Greta.io, or GretaScript on Twitter. He lives in Stockholm, Sweden. He studied information technology at Linköping University in Sweden, and then attended hacker school in New York City. He became a full-stack developer before co-founding Greta.io in 2014. And they provide that peer-to-peer JavaScript code for shortening web page load times and reducing bandwidth consumption. So again, thanks for joining us live today, Dennis.
Yeah, thank you.
Tell us what is Greta.io and how does it work?
We call ourselves a distribution script, which basically means that we try to do distribution in a very smart way inside your clients. And for the browsers, it's JavaScript. For other platforms, it's SDKs and things like that. So it's basically a small JavaScript that you implement, similar to Google Analytics, copy and paste the script you get from us. It will then serve images, audio, and video content for your site as default. And the benefits is that you get content faster, which means for images, the page will finish loading faster. So that's really good for your page load time, which is good for user experience. But when it comes to video streaming, both live and VOD, you will get usually a higher quality on average. So if you use one of the adaptive streaming protocols, HLS-, you will give your users a higher resolution because usually we can find a faster path to get the video chunks to the end users. So basically, everything we do, we try to make in the sense that it makes sense for the end user's experience and makes their experience using the web better. So let's look at how it works for a small neighborhood, basically. So this is a very simplified case, but it sort of points out what happens. So in the middle there, we have the server, and then we have a few different users, and they are spread out throughout this small neighborhood, and they are numbered. So if we take the blue person over at the 1, he's very far from everyone else. So he will go to the server because that's the nearest point and best path to get the content. But if you take the guy number 2, he could get the content from someone that's closer. So if 3 is already on the site and has the content, the number 2 could load it from number 3. And as you see here, you would have a really fast path between them because you wouldn't have to go too far in the network. And we do a lot of stuff to figure out the network topology. So how far are the users from each other? And when you could go as super local, as you see by 5 and 6, they are people in the same network. That would one load the content from the other one and one from 4 or someone else close to them or the server. So we always try to make the best decision for getting the data in the sense of one peer, multiple peers, or server. So let's look at quite quickly how it, what steps a computer or peer takes when it joins a Greta enabled site. So like normal, the client, Sophia, in this case, would load content from the server. So she would do normal request, get a content, and in that content, you would have the Greta script. And the Greta script would then make, if this is your first time learning, a request to an API server. And this request basically contains some metadata that allows you to bootstrap your connection to the peer-to-peer network, and also some information about who you should be getting content from and how you can make sure to try to optimize the path, ISP, geographical locations, and things like that. So when you have that information, you can connect our signaling system. The signaling system is similar to any WebRTC application. You need to exchange the offer and answer, and you can do ICE as well to get the connection set up. And that's for data channels, it's the same as when you do video chats. So no difference there in the setup process. Just make sure to also create a data channel. And when we now have a new user, Emma, here, she'll do all the same steps. And then Sophia, in this case, would send her an offer and say, here, do you want to connect with me? And Emma could then make a decision. Do I have all the peers I need? Do I don't think I have any content Sophia needs? And you could decide to make a connection or not make a connection. If you decide to make one, you create the answer and you send that back. And then you get onto the data channel and the peer-to-peer connection. And in this case, they both set up the peer-to-peer connection with each other, and now they can start requesting content. So in this case, Sophia's page is going to load an image or a video chunk or anything else. And then we make the decision, is it best to get it from a peer, Emma in this case, a server, or maybe multiple peers? In this case, it's best to get it from Emma. So we send over a request to Emma saying, we want this content. Emma will then send us the content using peer-to-peer technology in the data channel. And when we have all the pieces, we show it to Sophia. So that's sort of the steps, and it's really simplified in this case because it's just 2 peers and you want to have a higher density in your network because the number of POPs you have makes the biggest difference on the performance of the network if you have a good implementation on top of it. So sort of the density is important in this sort of a case. So that's just a short walkthrough, and now I think some questions is good.
Great, excellent. Yeah, thanks for walking through on that. So, are there any particular types of files or content that you prefer to serve on Greta, or anything that is particularly good at?
Yes, so we built the system in a way where we try to think about it more as data delivery or data delivery infrastructure than like a specific, it's not a video streaming service. It's a data delivery network, and that's what we're building, which means that we built it in a way that you can ask it for a key and it will give you back the binaries. That's like the core of it. And then of course we built like all this, if you think of that like a box, and then we built like all of these smaller like things on the side, which is basically just how do you handle this type of binary data. And then you have a bunch of like the normal stuff like a downloadable, an image, video chunks, and things like that. So we made like all of the like standard files, you could say, like images and video, things like that. But in the sense of it, you could move any binary data or any data.
Right. Very cool. And we just had an interesting question come in from Oscar here. It says, how do you know that you're sharing the latest data, the latest version of a piece of data when you share it peer-to-peer?
Yeah, so we also built a system where you can actually like invalidate content in the network. So similar to like a CDN, they usually have like a purge or clear cache button, which basically clears their servers. And then you still have your, like the end client still need to like either do this if modified sends or let the cache header run out. We can do that in the browser. So we can publish a message that is then gossip about in the network that says this content is not valid from this time. So if you have an older version, it's not valid to use. So you should both publish that I don't have the content anymore because it's invalid, or download it from the server. So if you use Greta and do that, we allow you to do it on like just a button on our homepage for the full stuff, or you could use an API to do it. And then they will sort of fill the network in a smart way. So when you hit it, you won't like DDoS yourself. So that's how we do it.
Very cool. Excellent. Yeah, great question, Oscar. Thank you. How does it work with live streaming video and larger pieces of volatile data like that, I guess is the way to put it?
So live streaming, there are a few ways to do it. There are I would say the most cases we see today is HLS or Dash people decide to use, which is basically chunk-based and manifest-based. So basically there is a XML similar file saying like, this is the available streams and you should refresh it this often if it's a live stream, or if you get the full thing if it's not live. And then like for every chunk, we can make a decision in the network and say, is there any peers to get it from? Or is there like, should we go to the server? So basically the people in the very front will be filling up the peer-to-peer network. And then since this refresh rate is current, then it will be getting data out in the network like that.
Every chunk of video is treated independently, and I might pull chunks of video from different peers in the network over time.
Yeah, and you might actually pull different pieces of this one chunk from different. So you can go like really like parallel, if that's like a good word for it, by down for every chunk basically. So when you like, it's very, very like dynamic and extremely non-stable. So it makes decisions for every piece, every time, and like in real time, all the time. And there are services sort of like multi-CDN things, which are very, very statical. Like you get like one place to get it when you sort of load a page. It basically very often only based on like your ISP and location.
Right.
So, and then like if that doesn't work, it's sort of out of luck. But in this sort of system where you have a lot of changing environments, like people are joining, people are leaving, then you need to be able to do it very, very often and in very high speeds.
Very cool. Great. We've got a couple other interesting questions that have come in here. So Vladimir asks, what's the main interest of Greta? Is it to help users save money on CDN costs? And if yes, how much can you save? What's your experience?
So that's something that we see as a bonus, and our customers tend to see that as well. Like saving money is always nice, but very, very many have a hard time doing live or backlist streaming in good quality. So the first thing they want is the quality improvement.
Right.
Being able to deliver it a higher quality video stream, but also actually know that this will work when we have a big interest in something. We have some customers that also, like when they get really big in an area and you have like really big events like say football games and things like that, it doesn't matter if they have like 4 CDNs because they will all just have servers in data centers. And they actually see problems way further out in the network, like even in like multifamily houses. They usually have like one cable in the basement, and they are starting to see problems inside the houses. So if everyone wants this content in full HD, you don't have enough bandwidth in that building. And they can't go there and put a server in. But with Greta, you get that feature, you get pops inside the building, so then you can actually deliver the video to people that otherwise wouldn't be able to do it in a good way.
Well, that's really interesting. I've always thought of this as, I guess, a larger geographic area that people are benefiting from their peers. But like the diagram that you showed in your slides, it really could benefit people in the same building together. Very localized benefit, and I don't know, perhaps that's where the most benefit is. I'm not sure.
Yeah, you can sort of, when you build a network, you want to spend quite a lot of time thinking about like, how do you like organize or control the peers in the sense of how they connect to each other. You don't want setting up connections, either though WebRTC have gotten a lot better, it still takes time.
Sure.
So you don't want to spend time setting up like dead peers you will never use for anything.
Right.
Like you want getting info from them, you won't send anything to them. That just takes time and is inefficiencies in the network. So you want to be able to do it in a intelligent way.
Great. Okay, we've got another question here from Eli, and Vladimir says thank you. Thanks for the question, Vladimir. Eli asks, what sort of issues have you seen with data channel implementation? So what sort of challenges have you run into?
Yeah, in the beginning they were quite shaky and they weren't performing super well. I mean, if you look at what the majority of WebRTC community have been doing with WebRTC video chat, which makes that Google and other browser vendors have spent a lot of time on like optimizing and building that part out first. So that was sort of a challenge in the beginning, like starting to like raise like knowledge about that this is a valid, like the data channel is valid for other things and you should spend time there because we can use it for good things. But as it has improved, there have been less and less problems with it, and the performance and throughput of it has really improved. So I think in the beginning there were a lot of challenges, but they ain't relevant anymore. So
it's similar to the challenges with WebRTC as a whole. It's just maturing over time, and it'll continue to get better as it matures.
Yeah, and the data channel has always been a few steps behind, I feel like.
Right, right, exactly. Video is what people come to first, and then they think about the data channel. So, okay, great. A comment from Sebastian, who says that he's reading the documentation on your website and he really likes the gossip protocol. Maybe you can explain what that means for the rest of our people.
So the gossip protocol is built on a paper that we haven't written. We just think it's a super cool paper by modular multicast. So basically, it's a way to tell the network something, to broadcast a gossip, basically, and without any acknowledgements, being able to know that very, very, very likely that everyone has gotten the message.
Okay.
So you publish a message, and then every person that gets it will like see, do I have this message or not? And if you don't have it, you go back and ask for it. If you do have it, or even if you asked for it when you got it, you pick a random peer and send it. And you iterate that enough times, and you will see that like the likelihood goes like this.
Mm-hmm.
And then you will know that, yeah, without any centralized point and in a very, very scalable way, everyone has, with an insanely high probability, gotten this message.
That's great.
We use it internally for some stuff and really like it. That's why we put the API out there to let people play with it. We had a few people do some fairly cool things using it, mostly plays or hacks right now, but a lot of people like it. And when you know that sort of like theory and technology is out there, you start to think about use cases for it.
Yeah, very cool. So I think I saw a blog post that for your messaging infrastructure internally to Greta, to the application, you're using a service called nats.io, Nats.io. I was wondering if you could tell us a little bit about that and why you chose that for your messaging platform.
So we tried, I think by now, like everything we can think about when it comes to signaling. It's a very, very central part if you're gonna build this sort of system in like high scalable and in enormous amount of users.
Yeah.
And so we, as we said in the blog post, we started out with like an Nginx thing.
Mm-hmm.
So you did a WebSocket connection, and then you had to post the message you wanted to send to an API, and then it would be sent to the Nginx server and forward to the client. That's not fast enough, I think, is our feeling. It scales well, not fast enough. So we did try Node and all those. We didn't really get them to scale as well as other things. So we built the system using RabbitMQ and Erlang as one iteration, which scaled very, very well. Erlang is special, but it's really good at concurrency. It's sort of what it's built for.
Right.
But then Nats sort of started to come along. It's done by Apsera. It's super fast and very easy to configure, but it doesn't have a lot of features. But I don't need all the features that like RabbitMQ has. I need the ability to move messages really fast. So we played with that and built a Golang proxy, basically, that takes in a WebSocket connections and allows you to forward messages into the NAT system. They just released 0.8 with an auto clustering version, which means that you can basically set up like seed servers that are really small. You never connect to them. You just use them to bootstrap like your NATS infrastructure, which makes it really easy to manage like a globally distributed signaling system as we have.
Excellent. Very cool. Yeah, I'll after our show, we'll be posting the recording of this online, of course, and I'll include a link to that blog post and about NATS in there. It's definitely interesting to learn more about. So what other scaling challenges have you run into with the data channel? Is it primarily around that signaling layer that you use NATS for now, or are there other technical challenges you ran into?
There are limitations in the clients in your browsers that you have to be quite aware of. Like when you do the video case, there are a lot of reasons why you won't create too many peer connections, because it just won't work. Like you won't have a mesh network like doing video calls with 100 people. But when you only use the data channel, you can like build bigger networks. You can have more connections, but you can't have too many. Then you start getting problems. You also need to be very aware of like that you never sort of overthrows the client with either requests or messages of any kind, which is also not really a normal case for. It's very different from when you do the video stuff. So I think mostly like being very aware of the limitations of the clients and Chrome and Firefox.
Yeah, and I suppose you just have to experiment with what the right limits are that you can hit.
Yeah, it depends a lot from every case how you design the system and how you like think about it. So it's hard to say like this is the hard number because it's very from every system.
Sure.
And I would like to say also when it comes to like there's a bunch of settings on the data channel. They are really cool and quite powerful. But it's also, the boring thing with them is also that you have to sort of figure out a way to test what's the best for your use case.
Right.
Like reliable, non-reliable, order, non-order, max transmissions and things like that. So that was sort of I think that was a big step for us when we built we built small testing programs basically that allows to test like change parameters like by running and then graph the results and see like where do we find good like for our systems. I think building and like testing them in a actually like measured way is very good because it makes quite a big difference.
Yeah, that's a great point. I'm sure most of the time, and if you're just building a text chat over the data channel, then probably you leave a lot of settings default and you don't necessarily need to tweak them a lot. But in a higher performance scaling situation like you're dealing with, doing more comprehensive experimentation with that is really good. So there was some criticism of the data channel a few months ago, particularly around permission side and whether, because in as you know, and for our viewers, anytime that you turn on someone's camera or microphone, you're through the get user media, you're asking, the browser is going to ask them for permission and they have to hit approve or deny. So there's good permissions around video and audio. The data channel does not require that users have permission. And in fact, I imagine the vast majority of visitors who are in effect using Greta script they don't realize that this is going on behind the scenes and that it's to their benefit because now everybody in their building can see the HD video, but they don't realize it. And not in your use case, but in other use cases of the data channels, there's been some concern that users don't have an opportunity to give or deny permissions for the data channel usage. What do you think about that?
Yeah, I think your search said it quite well. That I think the perception when like video chatting have been so strong in the WebRTC space, a lot of people forget that it's a peer-to-peer stack. That's what it is, and that's how it's built.
Right.
And I think that makes sense to allow people to make connections. If you're building a peer-to-peer stack, that makes sense. Recording them is a privacy sort of interruption. Sure. I can't basically not send anything over a data channel that I couldn't send over a normal HTTP or a WebSocket connection.
Right.
So from the privacy sort of thing, it doesn't really introduce any new data for me to offload. I think it's good though that using the default interface is coming, because that makes it easier to explain to people what's going on and how it works. And people that sort of would get into those problems, they would be aware of what they are doing.
Right. Yeah, that's a good point. Okay, we've got another question from Vladimir in here that's probably a good one for us to wrap up with, although if anybody else does have another question, we're kind of at the end of our time limit here, but if you ask it quickly, maybe we can fit it in. But Vladimir wants to know, what are your next steps in terms of technology development for Greta, and what's your overall vision for the service?
Yeah, so we always iterate quite fastly. We are growing. We're a very small team right now, but we are growing quite rapidly and adding quite a lot of users. Right now, we let basically anyone try it out to see the use cases. Very often, when you explain the the benefits and how it works, people will understand what they want to use it for. And we see a lot of different things. We see everything from, like, as we talked about, normal like video pages, play video faster, show videos, load images, but we also see a lot of things in spaces like phones and IoT things. So we think about ourselves as an infrastructure layer, and that's what we're building, which makes it possible for us to think about it in a way like, how do you move data intelligently? And you run into things like, could we use information we know to do multi-CDN for every decision? It's much more simple to do that than to decide by all these pairs, but it's something our customers are looking at. So we're growing rapidly and trying a lot of things. I don't know if that asked this question completely, but
no, I think it's great. Yeah, so I mean, your vision is to be an infrastructure layer to any of those applications. Yeah, which is great. One last question here from Ray, who wants to know if you have any recommendations on a good project to run for learning the data channel, or maybe a good source in particular.
I don't have any like tutorials or things in mind directly. I think the most basic thing is if you have done like a video chat before, try to move your text chat from WebSockets to data channels, then maybe try to add file sending to it. So that's like normal steps to like build on top of what you might already know about WebRTC.
Right.
Trying to build something like we do involves quite a lot of like other stuff than the data channel. So it's not really a super good case for like learning the data channel, because there is a lot of other stuff.
Definitely more of an advanced use case for sure. But yeah, thanks for the question, Ray. And I have a few links I'll put in with the blog post where we put the recording of this session as well. Definitely there's HTML5 Rocks has a number of good articles on WebRTC, including one on data channels. And you might also want to look at WebRTC.org, and WebRTC-experiment are also have a lot of good examples of WebRTC quick start projects that you can work with. This has been really interesting, and I appreciate you spending the time with us, Dennis. Are there any other last comments that you want to make, or anything about Greta that you'd like to promote or encourage our viewers to check out?
No, I'm just happy that people start to think about WebRTC as something more than video chat.
Yeah, me too as well. We have a lot of fun building the video chat style applications, but it's always good to see people thinking about something a little bit beyond that, more creative uses of the video, or things that have nothing to do with video at all, and specific use cases around the data channel. So a lot of really great information here. Thanks again for your time, Dennis. Appreciate it. I hope we sparked a little creativity in some of our viewers as well today. And that some of them will also check out Greta at greta.io, or on Twitter, GretaScript.
I could just add that we have a public Slack channel, slack.greta.io, and I'm Dennis in there if there is any follow-up questions or things like that.
Excellent. Thanks again for joining us today in our Real-Time Weekly Show. Thanks again for your time, Dennis. If you all are interested in signing up for Real-Time Weekly, if you're not already, it's realtimeweekly.co.